Welcome to the DIY Honda Garage channel. DTC P0108 indicates a high voltage condition in the MAP, manifold absolute pressure sensor circuit. This diagnostic trouble code is related to the vehicle's fuel and air management system and is monitored through the powertrain control module, PCM. The MAP sensor plays a critical role by measuring the air pressure entering the engine's intake manifold, allowing the PCM to adjust the fuel injection and ignition timing accordingly. If the voltage signal from the MAP sensor exceeds the threshold of 4.49 volts, the PCM sets this DTC and triggers the check engine light to alert the driver. Diagnosing this issue effectively ensures optimal engine performance and fuel efficiency. The subsequent slides will provide a comprehensive troubleshooting guide for effectively diagnosing and addressing DTC P0108 in a Honda Pilot from the years 2016 to 2022. The MAP sensor, located near the intake manifold of the engine, is responsible for measuring the pressure of the air entering the engine. This information is crucial for the PCM to determine the appropriate fuel-to-air mixture needed for optimal combustion. When the MAP sensor detects a change in air pressure, it sends an electrical signal to the PCM, helping regulate engine performance. The sensor utilizes a 3P connector for its electrical connections, making it essential to ensure that this connector is functioning properly. If the voltage reading exceeds 4.49 volts, it indicates that the circuit is providing a high voltage signal that is not within the expected range. Proper location and role understanding is vital for effective troubleshooting of the P0108 error code. Several factors can contribute to the triggering of DTC P0108. One of the primary causes is a faulty MAP sensor, which may give an inaccurate voltage reading due to internal malfunction. Additionally, wiring issues such as frayed or damaged wires can lead to improper voltage transmission, causing the PCM to perceive a high voltage condition. Poor connections at the MAP sensor or the PCM can also result in incorrect current readings, triggering this DTC. Lastly, intermittent electrical issues may arise in a fully functioning system, leading to temporary error codes. Thorough investigation of each potential cause is essential for proper diagnosis and remediation. When DTC P0108 is present, the most noticeable symptom is the illumination of the check engine light on the dashboard. This warning signals that there may be an issue in the engine management system requiring attention. Drivers may also experience poor engine performance, such as reduced power or sluggish acceleration due to incorrect air-fuel mixture adjustments influenced by erroneous MAP sensor readings. Increased fuel consumption can occur as the PCM attempts to compensate for perceived performance issues. Other symptoms can include erratic engine operation or stalling, exacerbating the urgency for a thorough diagnosis. Understanding these symptoms can guide technicians in troubleshooting effectively. In the first troubleshooting step for DTC P0108, begin by turning the vehicle's ignition to the on position without starting the engine. Using the HDS, Honda Diagnostic System, access the data list to check the MAP sensor's current voltage reading. The threshold value for the MAP sensor voltage must be evaluated. Any reading exceeding 4.49 volts indicates a high voltage condition. If the current conditions match this threshold, it confirms the presence of failure. Proceed to the next step in the diagnostic process. If not, consider the possibility of an intermittent failure and check the connections between the MAP sensor and PCM for integrity. This verification step is foundational to understanding if the issue persists or if it was transient. For troubleshooting step 2, first, turn off the vehicle to safely perform the disconnection needed for this procedure. Detach the 3P connector from the map sensor, and then create a jumper wire connection between terminals A and B of the map sensor 3P connector. These terminals correspond to the sensor's voltage and ground signal. Now, change the vehicle's ignition to the on mode to check new readings through the HDS. Monitor the map sensor's voltage again. If it remains above 4.49 volts, it indicates that the sensor likely needs replacement. Conversely, if it does not exceed this threshold, then the issue may lie elsewhere in the system, prompting a move to the next diagnostic step. In Step 3, turn off the vehicle once again and remove the jumper wire that was previously connected to the map sensor. You now need to turn the vehicle key to the on position. At this point, measure the voltage between the specified test points. Map sensor 3P connector terminal number 1 and terminal number 3. This check is crucial because it assesses whether the SG1 line, which connects the sensor and the PCM, is functional. If you find that the measured voltage is approximately 5.0 volts, proceed to the next troubleshooting step, confirming that the power supply to the map sensor is intact. If the reading is not within this range, this indicates a potential fault in the wiring or connectors and prompts further investigation. For Step 4 of the troubleshooting process, ensure the vehicle is turned off and jump the SCS/SRS connector short line using the HDS. After waiting for more than a minute, disconnect the PCM connector, specifically connector C, which is a 51-pin connector. Now, check for continuity between test point 1, MAP sensor 3P connector terminal number 1, and test point 2, PCM connector C, terminal number 33. This inspection is necessary to confirm whether the SG1 wire responsible for transmitting the voltage signal is undamaged. If continuity exists, it confirms that the wire is functioning properly, allowing you to consider potential issues with the PCM or other DTCs. If not, you will need to repair any identified breaks in the wire between the map sensor and the PCM. In the final troubleshooting step, begin by turning off the vehicle and jumping the SCS line with the HDS once more. This process prepares for continuity checking, so ensure to wait for over a minute. After this time has passed, disconnect connector C from the PCM. Following that, check for continuity between test point 1, map sensor 3P connector terminal number 2, and test point 2, PCM connector C, terminal number 45. This step will establish whether the PB wire, which also plays a crucial role in the map sensor's operation, is intact. If continuity is present, it confirms that this wire is functional, and you may then consider substituting a known good PCM or examining any relevant service information for other symptoms. If continuity is absent, repair any damages or open circuits found within the PB wire. After completing the necessary repairs related to DTC P0108, it is essential to verify the integrity of those repairs through a thorough test drive. During this drive, carefully monitor the vehicle's performance and ensure there are no reoccurrences of the DTC. Confirm that the map sensor is functioning correctly, facilitating accurate readings of intake manifold pressure. This process not only validates the repair, but also ensures that the vehicle operates efficiently under various driving conditions. A successful conclusion to this verification step means the issue has been resolved and the vehicle can return to normal operation. Always remember to reset the diagnostic codes after the test drive to confirm that the DTC does not reappear. To mitigate the risk of encountering DTC P0108 again, consistent preventive maintenance practices should be followed. Start with regular inspections of wiring and connectors associated with the map sensor and PCM to prevent electrical faults. Ensure that all connections are secure and free of corrosion, as these can lead to intermittent failures. Additionally, monitor the vehicle's performance routinely. Be vigilant for any signs of irregular engine behavior or warning lights. Establishing a schedule for maintenance checks helps catch potential issues before they escalate, improving the vehicle's longevity and efficiency. By prioritizing preventive measures, drivers can enjoy reliable performance from their Honda Pilot. In conclusion, understanding the function of the map sensor is key to addressing DTC P0108 effectively. By following a systematic troubleshooting approach, technicians can accurately identify the root cause of the high voltage condition in the map sensor circuit. Each step is designed to narrow down potential issues, allowing for targeted repairs that restore optimal functionality. It is crucial to ensure proper connections and wiring integrity for the map sensor and its circuit components throughout the diagnostic and repair processes. Finally, integrating thorough preventive practices into regular vehicle maintenance can greatly reduce the likelihood of recurrences of this DTC and enhance the overall performance of the Honda Pilot. Following these guidelines not only resolves the current issue, but promotes long-term reliability and efficiency. Please like and subscribe to the channel. See you next time.